Hey pre-calcers, if you're in period 2, what's up Jim White? What's up Michelle Mateo? What's up Dylan Rooney? What's up Daniil? I see you. If you're in period 4, you might be Sylvia, you might be Mara, you might be one of the Rileys. So we're taking a look at the 2.1, 2.2, 2.3 quiz. It looks like this. You've already seen this. This was posted on Schoology. I'm going to talk through how some of these problems work. I'll do my best along the way to remind you what sections each problem deals with. The first 3 are definitely from 2.1, so if you get stuck, remember you can go back and rewatch those videos on 2.1. What's going on here? We have to add or subtract as indicated and write the result in standard form. I'm going to color coordinate. I know that 4 is a real number. 7 is also a real number. 4 plus 7 gets you 11. Positive 11 at that. So you already can eliminate A and B. Your complex numbers are negative 8i and 5i. So negative 8i plus 5i. What's that going to get you? Negative 3i, of course. When you combine both of these together, 11 minus 3i is your best bet, which is going to match up with C. Pretty easy, similar to combining like terms. Next one has you foiling, so your first product is going to give you negative 21. I times I is going to be I squared, so keep that in mind. You're going to have to change that in a second. Negative 7 times negative 5 is going to get you 35 positive. I's along for the ride. So as we take this further, which of these can we rewrite? You should be saying that I squared can be rewritten as negative 1, which is going to give you positive 21 plus 35i as your answer here. And we see that that's definitely an option where both of these are positive. A is going to be your best bet. Next problem has you foiling, which is pretty much what we did in problem 2, just on some caffeine kick. So box method, I think, is the easiest way to show this. 6 minus 8, I on the side. Product of 6 and 8 is 48. 4 and 6 is 24. I is along for the ride. Negative 64 i's down here. Negative 8 times 4 is going to get you negative 32. I squared is also along for the ride. So keep in mind that when you start to combine these diagonal I terms you can combine. This gives you negative 40i, whereas you have 48. Deducting this 32i squared, which you should consider rewriting as really just 48 plus 32. It's going to give you the actor known as 40. So your answer needs to be composed of 80 and negative 40i, which is C. Again, these first 3 problems you can find in 2.1. I believe 4 is also seen there, so this is dealing with the quadratic formula. I'm going to assume that you have this copy down. Make sure that's in your notes for tomorrow. If we look at our term, we're just getting coefficients. A is 1, B is 1, C is also 1. These are based off of the coefficients, even though they're unwritten, minus the constant. So we have negative b, so negative 1 plus or minus the square root of b squared minus 4 times a times c. This is all over 2a, so 2 times 1. We can rewrite this as negative 1 plus or minus the square root of 1 squared, which is 1, minus 4. This is all over 2. We can then take this further. 1 minus 4 is going to get us square root negative 3. This is all over 2. You know how to rewrite this as 2 fractions, right? So keep that negative 1/2 plus or minus. I don't like having this negative, so let's take I out for a little spin. Put that in front of root 3. Remember, it's all dividing by 2. And this is what x is going to equal. So we're looking for the option that has negative 1/2 plus or minus I root 3 over 2. Best option is going to be C. Axis of symmetry, you should definitely have that written down in your notes as negative b over 2a. This is dealing with 2.2 where we started to graph these out. So b is 12, so we want the opposite of 12 all over 2 times 1, which is going to be negative 6, and that's equal to x. This is a vertical line that you can graph because it's the axis of symmetry. So D works the best. So you definitely need this in your notes. Or you can recall that this is a small part of the quadratic formula, which you already used in problem 4. The next problem has you going for x-intercepts, stating whether it crosses or just hits the x-axis and then bounces. So set all your factors equal to 0, or notice opposites. You still paying attention? You still there? That's crazy. When x is 0, you see that this has multiplicity of 2. So you know that this is going to hit and then bounce back. This is going to say one of your zeros is when x is 1 with multiplicity of 1. Again, this is based around the exponents that are either written or not written. Might help you out to just sketch those in if they're not there. This is also going to say x is 3, multiplicity of 1. So with multiplicity of 1, that implies that it's going to cross the x-axis. This will also cross the x-axis. You found this information in, I think, 2.2. No, 2.3, I'm pretty sure. So there was a lot of information in 2.3. So if you get stuck, go back and watch those videos. So when x is 0, you're going to be touching the x-axis and turning around. So the only option that really works with, again, positive 1 and positive 3 as your zeros, you can narrow it down just to A, B, and D. You know that when x is 0, this touches the x-axis and turns around. The only option that makes sense here is B. So notice that I'm using test-taking strategies to eliminate the answers that just don't make sense. You should always consider that whenever something is multiple choice. Well, let's keep it going. You're still with us. Next bit, do the same thing. I'm going to jump ahead here. My zeros, opposite of positive 1 is negative 1. Opposite of negative 4 is positive 4. Opposite of negative 1 is 1. But notice, what's different with this x minus 1? You'll notice that this has multiplicity of 2. So it's going to hit 1, bounce back. Whereas 4 and negative 1 just have multiplicity of 1, so they're just going to slide on through. So the best option for us, let's see, we're looking for negative 1, 4, and 1. C doesn't make sense. So now we're looking for where it says 1 has multiplicity. So let's see. Well, we're looking for negative 1 across the x-axis along with positive 4. The best option in this case is going to be D, because when x is 1, this touches the x-axis and turns around. This is based around multiplicity, so D works the best. There you go. Leading coefficient test. I think you saw this in 2.1, but it comes back again when we start to graph these. You'll notice that negative 5x to the 4th has a negative term in the front. Exponents even, however. So this is going to look similar to an upside down parabola falling to the left and to the right. So we're falling to the left, falling to the right. A is going to work the best here. Sketching these out always helps. Falling back on your core knowledge of quadratics will help. Y-intercept of the polynomial function for problem 9. Plug in when x is 0. So you have negative 0 squared, 0 plus 9, 0 squared plus 1. Negative 0 squared is really just negative 0. Multiplying with 9, multiplying with 1. Collectively, this is all 0 because anything times 0 is going to be 0. So that one's pretty easy. 10, sketch this out. Cross the x-axis at negative 2, 0, and 4. I have graph paper, so I'm going to utilize it because I got it like that. So got these 3 zeros, 1 at negative 2, 1 at 0, 1 at 4. I know that it's going to lie above the x-axis between negative 2 and 0, so it could look like this. I know that it's going to lie below the x-axis between 0 and 4. And I'm also using the lead coefficient as 1 or negative 1 to make the degree as small as possible. Well, I know that this is going to have to cruise through when x is 0, so one of my factors is definitely just going to be x, because it cruises through, and this has odd multiplicity, so we want to say it just slides through. We can assume that these will continue this path and go in this direction, so we know that this is going to look like a cubic function, so our leading term is going to have to be x cubed. This is just based off of end behavior. As far as framing the other factors, opposite of positive 4, it's going to be negative 4. Throw x to the front. Also with this, opposite of negative 2 is positive 2. Put x in front. So your function in this case is going to be composed of, drum roll please, x plus 2, and also x minus 4. For the actual quiz, I'm going to let you leave this in factored form because I'm cool like that, and I know you know how to FOIL this. If you're curious as far as the quiz here, this when distributing x gets you x squared plus 2x. When you FOIL this out with x minus 4, or use box method, this will give you x cubed plus 4x squared, minus 4x squared plus 2x squared minus 8x, which is collectively x cubed minus 2x squared minus 8x. So the closest thing in this scenario would be B. Next one. You got 2 zeros here at 0 and 3. One, 2, 3. Lying below the x-axis between 0 and 3, definitely going to look like this. I know that one of the factors is going to have to be x. Maybe x squared. We don't know if it bounces back, but we know that one of the other factors is going to have to be the opposite of positive 3, which is going to be x minus 3. So this factor is based around this 0. And we actually don't see this as an option, so we can assume that this is going to have to be bouncing against x squared. So let's make this x squared. And we'll assume that this keeps going, so it looks like a cubic function. When you FOIL this out, this is going to get you x cubed minus 3x squared. The best option in this case looks like C. So notice that this hits all of the criteria. This was below the x-axis between 0 and 3, touched the x-axis when x is 0, crossed when x is 3. And we can assume that when it just says touch the x-axis at 0, that it's going to hit and bounce. So we can assume that there's even multiplicity. So hopefully this was helpful. Hopefully you use these hints as you work through tomorrow's quiz. Bring a calculator, bring your notes, whatever you think is going to help. Thanks for watching. Make it a point to subscribe below if you want to get more math help.